In this problem, conjunctions of the form P intersect Q are going to appear in both the givens column and the goals column because of intersection of sets being involved. Here is the problem. Suppose F and G are families of sets. Part A, this is kind of a mouthful, prove that the union of F intersect G is a subset of union of F intersect union of G. All right, so I'm going to attempt to draw some sort of picture to explain why this should be true. First, I want to make 4 sets here. Okay, and F and G are families of sets. So F is going to have 3 sets in it. And the family G, that's a G, is going to have also 3 sets, but it's going to be the bottom 3. Okay. And you notice that they overlap in the middle 2 sets. So F intersect G has 2 elements, okay, these 2 sets. And the union of F intersect G would just be the collection of all elements in either of these 2 sets. Okay. So it would be those 8 elements in this case. Now we're supposed to show that that's a subset of this. Okay. And so we need to sort of understand why each of these points is contained in this intersection. And that just means that it's contained in each of these sets, right? It's contained in the union of F and in the union of G. Okay. But yeah, these points are certainly in the union of F, right? In fact, these points together with whatever elements are in this set up here would be the union of F, right? And the union of G would be all these 8 elements plus whatever elements are down in this set. Those elements would form the union of G. And so these 8 elements in the middle here are certainly in both union of F and union of G. And so this is true. Now, it's actually not always true that the right side is a subset of the left side. And it's a little trickier to think about. I'll let you ponder it. My hint would be that it's possible for the same element to be represented by a couple different dots here, right? You could have a single element which lives in more than one of these sets. So you can think that through. Now let's try and figure out how to prove this thing. We have a given that F and G are families of sets, and here's our goal. And the definition of a subset would be that for all x is in the left side implies x is in the right side. And then we can let x be arbitrary, so we drop that universal quantifier. And we'll do direct proof on this conditional statement, so we can take the antecedent as a given and the consequent as our new goal. And on the right side here, we have that x is in the intersection of 2 sets, which just means, by definition of intersection, that x is in the first set and x is in the second set. And then that's a conjunction, so we can break it up into 2 separate goals. Okay. Just like that. Now we have 3 statements of the form x is in the union of some family of sets, and so we can write out definitions for that using definition of a union. Right? For example, x in union of F means there exists some set A such that A is in that family of sets and x is in A. All right. Well, we have an existential statement as a given, so we probably want to do existential instantiation right away. We will give the name A0 to an A for which this holds. And there's another conjunction, right? So we should split it up into a couple of givens. And okay, we're trying to come up with this, and A0 is probably going to do the trick for each of these goals. What do we have? A0 is in the intersection of F and G. That means, by definition of intersection, and also by the conjunction thing we've been doing, that A0 is in F and A0 is in G. So I've abbreviated a little bit there. And finally, that's pretty much it. We just need to combine these givens in the right order. So if we put those 2 together and put an and between them, then that's going to be just what we need for this first existential statement. And if we put A0 in G together with x in A0, that's going to be what we need for the second one. Okay, so because we have that sort of A0, that statement's true, and because we have this sort of A0, that statement's true. So let's write a proof. What's the first thing we need to say? Well, the reader knows we're going to prove this statement, and then the definition is this, and we're letting x be arbitrary to arrive at this goal, and immediately we are taking our antecedent as a given. So we have this goal. Okay, so we can say both those things at the same time. Suppose x is not just arbitrary, but an arbitrary element of the union of f intersect g. And we're going to show that x is in the union of f intersect the union of g. Okay. And it looks like the next thing that happens is we split that up into a conjunction and then into two separate statements. So maybe we should just mention that those are our actual two goals going forwards. I'll say that is that x is in the union of f, and put a little space there, and x is in the union of g. Okay, so those are our goals. Now we hop over to the given side, and we came up with this a naught at some point, because we had that x is in the union, which gave us an existential statement, and then we did existential instantiation. So we should introduce this variable a naught because x is in the union of f intersect g. There exists some a naught such that a naught is in f intersect g, capital A naught, and x is in a naught. Okay. All right, and that even really gets us down to here because we just broke up that conjunction into two givens. Now this a naught in the intersection became these two, and then we combined a naught in f with x in a naught to obtain this statement here, which gave us this existential statement, which was the definition of x in the union of f. Okay, so we say because a naught is in f, right? We just said a naught's in f intersect g, so our reader understands that a naught's in f. And also from the previous line, x is in a naught. It follows that x is in the union of f. And quite similarly, because a naught is in g and x is in a naught, it follows that x is in the union of g. Okay. And those two conclusions, that x is in these two unions, were exactly what we said we were trying to prove. So we're done.